Okay, so what we're going to be working on today is reducing algebraic fractions. So the first thing I do want to go over with you guys, since we're talking about fractions, is when is a fraction undefined? So a fraction being undefined should not be something that's new. Okay, it's probably one of the first things you learned about fractions. A fraction is undefined when you have 0 in the denominator of the fraction. All right, so let's take a look at the try this. It says, when is the fraction undefined? So right there, I want you to put down when 0 is in the denominator. All right, so remember the denominator is the bottom of the fraction. All right, and then it says, for what values of x is the fraction undefined? So sometimes when you look at the fraction, you can tell right away what value can you plug in for x to make the fraction undefined. If you have a hard time figuring out what would make the fraction undefined, just take the denominator and set it equal to 0. So why don't you write that down right underneath here. Set denominator equal to 0. And then you would solve for x. So let's just take a look at number 1. It does not matter what's in the numerator. It's what's in the denominator. I want to know for what value of x, what could I plug in for x that'll make 4x equal to 0. So we should be able to figure that out. 4 times what number is equal to 0? Well, that's 0. So x is equal to 0. If you're not sure, you take the denominator 4x and equal it to 0, and then you solve for x. Divide both sides by 4. 0 divided by 4 is 0. So the fraction is undefined when x is equal to 0. What that really means is that for this particular problem, number 1, your x can't be equal to 0 because then it's undefined. All right, so let's take a look at 2. So I want to know what value can I plug in for x here so that when I do x plus 4, I will get 0. If you're not sure, you take x plus 4 and you set it equal to 0. Minus 4, x is equal to negative 4. So my fraction is undefined when x is equal to negative 4. All right, let's take a look at number 3. For what value of x is the fraction undefined? So I'm not sure just by looking at it what number that is. If you do, that's fine. You take the denominator, 6x plus 18, set it equal to 0, minus 18. 6x equals negative 18, divide by 6, x is equal to negative 3. All right, now look at number 4. This one was probably a little bit more difficult. So you would want to take the denominator, 3x squared plus 10x plus 3, and set it equal to 0. And you're going to factor. So I multiply the first times the last. I get positive 9x squared. What multiplies, now I'm looking for what number is multiplied to 9, add to 10. That would be 9x and 1x. They get the same sign because of the positive at the end. And they're both positive 9 and positive 1. That gives me positive 10x. Bring down the 3 and the 3x squared. And now we are going to factor by grouping. I grouped the first two. Group the last two. GCF of the first two is 3x times x plus 3. I have a plus here. Put the plus on the outside. My GCF is 1 times x plus 3. So my factors are 3x plus 1, x plus 3. And remember, I want to know when is it going to be equal to 0. So now I make my t-chart. I get over here x is negative 3. Over here, I get 3x plus 1 is equal to 0 minus 1. 3x equals negative 1. Divide by 3, negative 1/3. So it's undefined when x is either equal to negative 3 or when x is equal to negative 1/3. So I have two answers there. All right, so now we're going to move on reducing algebraic fractions. So let me just clear my screen here. Okay, so reducing algebraic fractions. So the first thing you're going to do is you're going to factor the numerator and the denominator completely. So that means to factor until you can't factor anymore. If you have a binomial that can't be factored, put parentheses around it. When we reduce, you're going to reduce the numerator with the denominator. Remember, you can only reduce factors though, so that means you have to have multiplication in between the factors in order to reduce. So let me show you what not to do. All right, so take a look at number 1. You can't do this. Oh, I have an x here and x there, I'm going to cross them out. Can't do that. Look at number 2. I have an 8 and an 8. I'm going to cross the 8 out. I'm going to cross the x out with the x. I'm going to cross the 2 and make the 4 2. Can't do that. All right, same thing here. You can't do, all right, x, 3, 3. Doesn't work. All right, so that's a big no-no. All that does not work. All right, so we need to factor. You're going to factor the numerators. You're going to factor the denominators. So take a look at number 1. In the numerator, I have a 3x. You can't factor 3x. All right, that's all because it's a monomial. It's already really in factored form. It's 3 times x. So just rewrite it, 3x. In the denominator, I can factor x squared plus 2. There is a GCF. The GCF is x times x plus 2. So notice that there is multiplication in between the 3 and the x, right? Because those are factors, 3 times x. And there's multiplication in between the x and the parentheses. Those are your factors, x and then the parentheses, x plus 2. Now you're going to reduce. Start all the way on the left in the numerator and work to the right. Start with the 3. You have a 3 here. Does that reduce with anything in the denominator? No, I don't see a 3 or a 6 or a 9, something that I could reduce it with. So then you go to x. I have an x in the numerator, so that means I'm looking for an x squared in the denominator. And yes, I have this one. It's this one. You're not looking at the one in the parentheses. Remember, the one that's in the parentheses is grouped with the plus 2. You can only look at the one that's here on the outside. So x and x reduced to 1 because anything divided by itself is equal to 1. So my final answer would be 3 is in the numerator. In the denominator, I have x plus 2. All right, so let's take a look at number 2. All right, in the numerator, I have 4x plus 8. There is a GCF. The GCF is 4. And then I have x plus 2. And in the denominator, we can factor the denominator. So if you need to factor this on the side, you can do it right up here. That was looking. So I would just factor this on the side here so you have enough room because you're going to have to factor by grouping. So right, we multiply the first times the last, we get negative 8x squared. What multiplies 8x minuses to 2? That would be 4 and 2. All right, so I need to get negative 2. They get different signs, so it's negative 4, positive 2, negative 8 at the end, and x squared at the beginning. And then you're going to factor by grouping. The GCF of the first group would be x times x minus 4. GCF of the last group would be 2 times x minus 4. So my factors are, now I'm going to go back down to my fraction here, x plus 2. And x minus 4. All right, so notice that there is multiplication here in between the 4 and the x plus 2. And I have multiplication in between the x plus 2 and the x minus 4. You may not reduce the 4 with the 4 on the inside of the parentheses. Because now this 4 is on the inside of the parentheses. It's attached to the x. It's x minus 4. You have to think of this as one whole thing, not as just 4. All right, so start in the numerator, work from left to right. So I see here I have a 4. I'm looking for in the denominator a 4, an 8, a 16, a 12, something that I can reduce it with. You can't do this 4 because that's inside the parentheses. So there's nothing. Now I go to the parentheses, the x plus 2. That means this guy here. I'm looking for an x plus 2, the whole entire factor to reduce it with. And then I notice in the denominator, there's an x plus 2. Those reduce. It's the same thing. They reduce to 1. So what's left in the numerator? 4. And what's left in the denominator? X minus 4. That's my answer. All right, so let's take a look at number 3. 3 is a special one. Notice I have x minus 3 and 3 minus x. They are actually complete opposites. All right, notice that here I have a positive x, and here it's a negative x. They are opposites. A negative 3 and a positive 3. They are opposites. This actually reduces to negative 1. So right here on the stars, I want you to write opposites, reduce to negative 1. So this is another example of opposites. 8 minus x, x minus 8. That reduces to negative 1. All right, so that's an example. Another one would be x minus 4 and 4 minus x. That reduces to negative 1 also, as long as they're opposites. This would not be an opposite. 4 minus x, 4 minus x. Those are not opposites. Those are the same thing. That reduces to 1. All right, so just make sure that they're both negative and they're in different orders. This is not opposites. 4 plus x, x minus 4. Those are not opposites. And the reason why is because look at your x values. It's a positive x and that's a positive x. The 4s are opposites, but not the x's. So that reduces to nothing. Okay, that would just stay like that. Okay? All right, so let's take a look at 4. Okay, so look at number 4. I have 12 minus 6x. So I actually have a GCF. The GCF is 6. So that would be 6 times 2 minus x. Make sure you keep it in the right order. It's 2 minus x. You cannot write this as 6 times x minus 2. That would be different. All right, so make sure you do write it the correct way. All right, so it's 6 times 2 minus x. And in the denominator, I notice I have x squared minus 4. That is the difference of two perfect squares. That is x plus 2 and x minus 2. There is multiplication in between the 6 and the parentheses and these two parentheses here. Start over here on the left with the 6. I'm looking for a 6, a 12 in the denominator. I don't see it. Go to the next thing. I have a 2 minus x. I'm here now. I'm looking for a 2 minus x. Oh, I see here I have an x minus 2. These are opposites. Opposites reduce to negative 1. So my answer would be 6 times negative 1 is negative 6 over x plus 2. Now notice where I put the negative. I didn't put the negative in the numerator. I did not put the negative in the denominator. I put it right even with the bar. That's where I want you to put the negative. Because if by accident, if you do this, negative 6 over x plus 2, that's okay. But if by accident you do this, 6 over negative x plus 2, that is wrong. It would have to be in parentheses. So your best bet is just to put it right even with the bar of the fraction. All right, let's take a look at number 5. All right, number 5, look in the numerator, I have a GCF. The GCF is ax times a minus x. In the denominator, there is a GCF. I have a squared x times x minus a. So there is multiplication in between the a, the x, and the parentheses. The a squared in the denominator, the x, and the x minus a. So we're going to start with the a. I'm looking for another a in the denominator. And then I notice here I have a squared. That means you have 2 a's in the denominator. I have 1 a in the numerator, 1 a in the numerator, 2 a's in the denominator. So that means one of them will reduce, and I'll be left with an a in the denominator because there's more in the denominator to start with. Go to the next thing. I have an x and an x. That reduces to 1 and 1. A minus x, x minus a, that reduces to negative 1. Make sure you only put the negative in the top of the bottom, not both. So what's left in the numerator? 1 times negative 1 is negative 1 over. Make sure that negative is with the bar. In the denominator, I have a times 1 would be a. So it's negative 1 over a. And then let's take a look at number 6. All right, so 4x plus 6, there is a GCF. The GCF is 2 times 2x plus 3. And then I look in the denominator, and I have a trinomial, so I'm going to have to factor this guy. Now, since I am actually reducing, and knowing that I'm going to have things that reduce to 1, or in what you guys would say cross out or cancel. They don't actually cancel, they reduce to 1. If I have a 2x plus 3 in the numerator, most likely I'm going to need a 2x plus 3 in the denominator. But let's check to see if that's what we actually get. So I multiply the first times the last, and I get negative 12x squared. So I need a 4 and a 3. That gives me the 1 in the middle. 4x and 3x. I need negative 1, so I need negative 4 and positive 3. That gives me negative 12x squared when I multiply, and negative 1 when I combine like terms. Bring up the 6, and bring up the 2x squared. And now we're going to factor by grouping. So my GCF here would be 2x, so it would be 2x times x minus 2. GCF in the last group would be positive 3 times x minus 2. And then my factors would be 2x plus 3, which is what I had, because that's what I thought I would need. And then my other factor would be x minus 2. So it's just a little way to possibly help you out. All right, now let's reduce. I have multiplication here and here. Let's reduce. I have a 2. Does 2 reduce with anything? Nope. You can't take it away from this 2 or this 2 or that 2. So then I have to go to 2x plus 3. 2x plus 3 and 2x plus 3 reduce. What's left in the numerator? I have a positive 2 over in the denominator x minus 2, and that's my final answer. All right, so that's it, and I will see you guys tomorrow night. Have a good night. Tomorrow in the afternoon. Sorry, not tomorrow night. I'll see you tomorrow morning. Have a good night.